Mazda is climbing into the driver's seat, and the spirited new 626 is about to take off, ready to make its mark on the highways of the world and ready to leave its mark on automotive engineering. The car you see here on the test run looks like a stripped-down current 626, but inside this engineering mule are the beginnings of a new breed of car. When we started the development of the new 626 in October '78, the effects of the oil crisis were still keenly felt. Smaller, more frugal cars were in the spotlight, but Mazda already sensed that the public would not settle for economy alone. But we had to be sure. So we went to the marketplaces all over the world and probed consumers' moods and needs. We focused not only on the particular attributes people sought in a car, but also on their lifestyles. Values, fashions, and product preferences were clarified, for the new car would have to be expressive as well as practical. The mid-size class car was clearly going to be the car of the future. Here was the potential for all the elements people were seeking. Not only fuel efficiency, but also power, comfort, handling, and roominess. Our job was to realize this potential for a car that could offer everything. Clear-cut objectives and exacting standards were established. There would be no compromises, no shortchanging. Our new 626 project team faced a task that would challenge their ingenuity for the next 3 years. Conceive, design, and develop the front runner that would lead the mid-size pack down the road into the 90s. We took our time analyzing design possibilities and building and testing 34 mechanical prototypes mounted in the shells of current models. But we knew our thoroughness would pay off. We were already confident that this was the beginning of a new generation of front-wheel drive cars. Only after 2 years of exhaustive simulation, design and laboratory and track testing did the new model assume a definite form. Our objectives were clear, but numerous options were open to us, and our engineers were given a free hand to explore them. The new 626 would not be limited by any existing design, components, or facilities. Everything would be new, from the engine and chassis to the body and production technology. Experts from design, production, marketing, and other fields met in marathon sessions to discuss the findings of early studies, and computerized analysis was employed to assess our data and possibilities. A major focus was the drive configuration of the new model. While the success of the front-wheel drive 323 GLC was a potent prod, we nevertheless reviewed the virtues and trade-offs of front-wheel drive and conventional rear-wheel drive layouts. Only after this careful evaluation did we settle on front-wheel drive, confident we could endow it with new dynamics while taking advantage of its inherent fuel and space efficiency. Motivated by the findings of our concept study, we also decided to add a unique 5-door hatchback to our sporty lineup that includes an elegant 4-door sedan and stylish 2-door coupe. The new 626 would have everything for every lifestyle. In our quest for a dynamic, organic design, clay models were sculpted and shaved and sculpted again. We sought lines that would be as efficient as they were elegant. The optimum form was a considerable challenge, since we had to reconcile the needs for economy, roominess, stability, and visibility. But it was clear from the start that a wedge shape and high rear deck would be basic components. These were key ingredients for reduced fuel consumption, low yawing moment, superior road holding, and ample cargo space. During hundreds of hours of testing, computerized measurement translated wind tunnel results into numerical data told us exactly what we had. Finally, our patience paid off in the top aerodynamic figures for drag and lift coefficients in the mid-size class. Like the exterior, the interior would have to be as functional as it was stylish. Bearing in mind the world's diversifying needs, we sought an interior that would offer gratifying space, functional ergonomics, comfort, and tasteful aesthetics. The instrument panel has been laid out precisely and conveniently, and the seating has been completely redone after extensive testing to determine ideal size, contours, adjustment and support. Independent panels were invited to offer their suggestions on seat interior trim and upholstery, as well as seat design, and materials were subjected to endurance tests to ensure the seat's durability. The front-wheel drive layout required a new transverse-mounted engine designed specifically for the new 626. We knew the kind of power plant we wanted. In addition to the current model's acclaimed low-speed torque for city driving, it would have to offer more power and higher RPMs. And it would have to be quiet, economical and responsive, as well as lightweight, compact and dependable. The new power unit would have everything, and everything would fit neatly. That was a tall order, but we filled the bill with our brand new transverse-mounted F-Series engine. A major consideration was the cylinder dimensions. We decided on a shorter stroke and larger bore for an optimum balance of high-end power and low-range tractability. And to maximize combustion efficiency, we carefully examined more than 20 different arrangements for the shape of the new combustion chamber. Reduction of mechanical friction was also a major development target, with close attention given to the bearing sizes and valve train, as well as the expansion forces of the piston rings. The meticulous effort to save weight and space was comprehensive, planned down to milligrams and millimeters. Part of this effort was reducing the number of parts, a move that eases servicing. And to save vital room and improve cooling efficiency, the water pump has been incorporated into the cylinder block. The lighter crankshaft and flywheel are complemented by the new cogged timing belt and V-ribbed accessory belt for lighter weight, less noise and greater efficiency. To ensure its reliability, the new V-ribbed belt was subjected to a shower of sand, cold water and pebbles before it was finally adopted. Employing computerized structural analysis and holography, we were able to slim down the engine block, but augment its rigidity, saving weight as well as reducing vibration. We were also working on a transmission that would complement the F-Series engine, a gearbox that would be quiet, compact and smooth. Fine mesh gears were a major development concern, since reduced size translated into reduced noise and vibration. To achieve the optimum balance of responsiveness and comfort, countless tests were performed on over 20 different types of front and rear suspension configurations. Grueling long-term trials followed, including comparisons with domestic and overseas competition. For the front suspension, we finally settled on an A-arm strut type for its contribution to subtle handling. Cornering is firm with the unique unequal length lower arms, which ensure balanced turning characteristics. A driveline center bearing equalizes the length of the drive shafts, eliminating torque steer. The suspension also incorporates anti-nosedive geometry for braking stability. For the rear suspension, the 323 GLC's unique TTL system was adopted, but not without further improvements. The links have been lengthened and the spacing between them widened over the 323 GLC's layout for greater resistance against twist force and for enhanced comfort. Suspension geometry has been further refined to lower the roll center to increase the roll camber, improving road holding. By the time testing and evaluation was completed, we had found a variety of ways to reduce noise and vibration while meeting our demanding handling and performance criteria. Among the new 626's noise suppression features are a semi-perimeter subframe, liquid-filled rubber engine mount, and radiator designed to act as a dynamic damper. Extensive computer-aided design and computer-aided manufacturing simulation were used to amplify abnormal vibration and tension. In this way, we could condense the fatigue of several years on the road into several minutes in the laboratory, a real boon to a shorter development process. By the time the Pilot 626 hit the test track, it was already well on its way to a blend of lively handling and gracious riding comfort. The new 626 had to prove itself in every way, everywhere. After grueling testing at Miyoshi, prototypes left for the highways and byways of 3 continents. There they would be confronted with the cold of North America, the heat of Australia, and the demanding roads of Europe. In the bleak, bitter winter of the North American prairies, life without a car is virtually unthinkable, and starter or battery failure or inadequate heating could literally mean the difference between life and death. Here were conditions that no low-temperature test chamber could match. The new 626 prototype would face some difficult trials. Stationary tests in -30°C temperatures examined starting, climate control, and a variety of operating switch and control functions. Even in this extreme environment, the prototype started up quickly and scored well in tests on the effectiveness of its defrosting system, interior layout, and air ducts. But the design and angle of the blower outlets were not up to our standards and underwent careful scrutiny. Out in a storm, the new 626 was far more stable than its competition as trucks roared by, additional confirmation of the new model's exceptional roadability. But the harsh realities of the bitter cold nevertheless taught us some lessons that we brought back to Hiroshima, where the new 626 prototype underwent further refinement. At the same time, another 626 prototype was at the other end of the thermometer and the other side of the globe, facing the dusty, jolting roads of inland Australia in the summer. Here we subjected the prototype 626 to tests on its resistance to heat, air conditioning performance, dust penetration, and handling on rough terrain. Using temperature graphing apparatus and chemical sensors in stationary heat tests, we checked temperatures at critical points on the car throughout the sizzling 50°C days. Although the new 626 proved superior to its competitors, several problems did arise in the fierce heat that reached 100°C in the closed cars. But these tests were not simply a competition between rivals. Rather, they gave us a chance to make sure that the new 626 would satisfy users in hot regions. Out on the road, we pushed the cars through the suffocating desert grit. It was an ordeal that taught us not only where the body sealing could be improved, but also where noise insulation was inadequate. Handling performance on the pitted dirt roads was gratifying, but we still had a lot of suggestions for the designers back in Hiroshima. Their task wasn't over yet. In Europe, we drove the 626 prototype along Belgium's cobbled streets, Germany's smooth autobahn, and Switzerland's treacherous mountain roads, relaxing only on the French Riviera to take final stock of the prototype's performance. Tests and adjustments were virtually continuous as our team checked the new model's sustained high-speed performance, handling, comfort, and noise. We had thought from the beginning that striking a balance between handling and ride for the international market would be no mean feat, and Europe proved us right. To ensure comfort, we had set the prototype suspension a little on the soft side, but drivers on the continent insisted it was still too hard. More tuning was necessary. The experiences in Europe led to the adoption of Mazda's exclusive electronic variable shock absorber system on the new 626. With this optional feature, only a flick of a switch adapts the damping for an ideal combination of response, stability, and riding comfort. As we wound through Europe, we grew ever more confident of the prototype's handling. Here was a roomy front-wheel drive car that responded like a thoroughbred sport model. The new rack and pinion steering communicated the feel of the pavement and responded precisely. Rapid lane changes assured us of the new 626's stability. And its grip on curves and easy ride on rough roads confirmed that this car would be up to any condition that the world might offer. In high-speed passing acceleration tests at autobahn speeds of over 150 kilometers per hour, the prototype was a satisfying, responsive performer. Its clean, aerodynamic lines transformed lower wind resistance into power the driver could feel. Moreover, the efficiency of those lines was visible in the frost pattern etched on the test car in Switzerland. By the time we stopped to relax and talk in Nice, we knew we had the car that would lead the way into the 90s. But back in Hiroshima, the fine-tuning continued as we patiently worked towards the total balance of chassis, power, aerodynamics and handling that we had sought from the beginning. Mazda circled the globe, trying to ascertain what people really wanted in a car. Of course, we brought back the technical information we needed on ways to improve our prototypes, and we spared no efforts to ensure the new model's vitality. But we also returned with a heightened sensitivity to the needs of today and tomorrow. Engineering for the roads of the world and the people of the world. That's Mazda. From design and testing to management and marketing. It may sound immodest, but it's true. The new 626 ushers in a new era in personal motoring. A mid-size car that offers not only roominess and comfort, but also economy, performance and response. With our receptiveness to the nuances of technology and people's needs, we are in the vanguard of today's automakers, confident that the bold new 626 will satisfy. The all-new front-wheel drive Mazda 626, the spirited one.